Hello everyone, welcome back to Python Full Course, and today we're going to look at functions. So let's get started. Alright, so what is a function? So a function is a piece of code that can take as input some values, and then it will execute a chunk of code, and then it can or not return some output. So this may seem very vague, and we're now going to make an example of a function. So to create a function, you have to use the def keyword. So def for define a function, I guess. So you have to put def space, and then you have to put the name of that function. So for example, let's say I want a piece of code that will take as input two numbers, and then it will return the sum of the two. Then I will name it add. And then I can have parentheses. I have to put them the parentheses, and I have to put a colon. Here I can put some code. So to make a comment, I can put your code here. So it's always nice to comment your code. Make sure to make clear, nice comments, and we have to give inputs to it because we can't just add anything. We have to add what they gave us. So we will name it A and B. So this is the first term. Let's name it easier. First term, second term. So I have the parameter first term, and then I put a comma, and I say second term. And now here I can use these variables, and you can think of it as like it's already assigned first term equal 10, second term equal 20 when you invoke it. So basically here in your code, you have access to the values of first term and second term. And what I want to do is that I want to give back the sum of the two. And to give back a value, I use another keyword called return, and this returns a value to the function to the one that called that function. So return first term plus second term. So this is very, very nice. So how do we test this function? Well, we can test it by just running a code. Then you'll see there's nothing wrong because there's no output. And you can write stuff in the console. So the console allows you to test some Python code and see what it produces as output. So what I have to do to invoke is that I have to do the name of the function, I have to put parentheses, and then I have to say the value of the first term I want. So let's say I want 10. And I have to say the value of the second, 20. And then you'll see it gives me 30. So let's try it here. So I add 10 and 20, and I'm expecting a 30 to show up. And as you can see, there's nothing that's being printed. And why is that? The reason why is that when you invoke functions, what they return does not get printed. So there's not a print statement that's going to print the value of that function. So what you have to do is that you have to wrap it in a print statement. So print add 10, 20. And now I have an unexpected end of file while parsing. And as you can see, it's a syntax error. And if you can see the error, then it's pretty good. But the reason why is that you have to have matching parentheses. So now if I put another parenthesis, the squiggly lines are gone, and I should see 30. So this is very good. And I guess now we'll go over some terminology. So 10 and 20 are called the arguments to add, and the parameters is first term and second term. So you can think of it as the argument is the value of the parameter. So 10 is the argument is the value of the parameter first term. So parameter is the variable, is the name of the variable in the function here, and the value is called an argument. So print add 10, 20. Notice how I can also invoke add as many times as I want. So add 30, 40, and I should get a 70. And I have a 70, which is very nice. I can also say print add 25, 40, and I should get a 65. So that's very good. So as you can see, functions are not really that complicated. You just have to put define, def, the name of the function, parentheses, then the name of the first variable you're going to pass in, so the name of the first parameter, and then second parameter here, and then ending parenthesis, you have to put a colon, and now you indent your code, and anything that is indented at that level will be executed when the function is called. Notice how if you put multiple return statements, it's pretty useless. So let's say I return like a 1 here. And if I run everything, you'll see that the return 1 is being ignored. I can also print something after a return. And then you'll see it's not being printed. And the reason why is that when you first encounter a return, the function will immediately stop and just give back the output. So there is also positional argument, which was what I was showing you all along. So positional arguments are when you just put the value in the parentheses. So you just say add, and then you say the value of the first parameter, 25 for example, you put a comma, and then you say the value of the second parameter, so I don't know, 90 for example. Keyword arguments, on the other hand, are different. Keyword arguments is that you have to specify the name of the variable, of the name of the parameter. So I can say add, and I have to say first term equal to 25, second term equal to 90. And you'll see that the two final results are going to be the same. So this and this are the same thing. It's just that sometimes when you're going to read other people's code, they may prefer to use this notation because it tells you what each argument you pass in represents. So 25 represents the first term and second term represents 90. In the case of add, it's pretty self-explanatory. But in more complex functions, keyword arguments are going to save you a lot of time because it's much more easier to read, although it is longer to type. So I guess now I'm just going to do another example of a function. And so I can say define greet. And this function is going to have as input a name. And then I have to put my colon, enter. And what I can do here is that I can execute the code I want. So let's say I want to print F strings, of course. So I put F in front of the double quotes, and then I say hello. And then I have to put the variable name, so curly braces to make sure it's a variable, then name. And I can do greet James. And I'll have hello James. So this is pretty useful because it prevents you from repeating your code all over again. So greet, let's say, I don't know, Pooky Codes. And then I can say greet Bob. And then you'll see I have hello. But let's say now I'm like, oh no, I don't want to put a hello. That's not how you greet somebody. How you greet somebody is that you have to greet them in French. So salut. And then you'll see it's just one line changed, and you see salut James, salut Pooky Codes, et salut Bob. So it's pretty genius. Whereas if you didn't use functions, if you did not use functions, then you have to do this. Print hello James, and then you have to say print hello Pooky Codes, and then hello Bob. And then you're like, oh, it's pretty fun. But then now you're going to be like, okay, now I have to change every single line to salut. So salut James, salut Pooky Codes, et salut Bob. Donc ouais, vraiment cool. So that's very, very fun. So would you rather change lines 3 times or just use a function and just change it at one occurrence? So of course, we're going to prefer functions. So define greet name and print salut name. I can greet James, greet Bob, and greet Pooky Codes. And now, as you can see, it's working fine. Notice how this function does not have any return value. So what I can do is that if you do want to know what is the return value of it, you can do answer is equal to greet James. So this will store the output, it's returned, and then you can say print answer. And you'll see that's going to be of none. So when a function does not return anything, it returns none. So this is pretty, well, intuitive. So same thing with the other ones. Answer of Bob, go, greet is equal to this part. And then I can print answer Bob. And oh no, repo.it is going to crash again. So we have to make sure that poor repo.it is not being overworked. So anyways, if it does, oh, it did run. So when run, you'll see that there's going to be salut Bob, and then it's going to print the answer of it, and it's going to be none. Let's make one last example of a function, and so this time it's going to be a bit more complex, so we're going to have to put more codes. So let's say that I had a student's grade, so we're back to list. Student's grades equal 90, 100, 23, 42, and then 83. Yeah, 42 is really not good. And I want to calculate the average, so I'm going to define average. It's going to take as input student grade, student grades, and what I'm going to do is that first I'm just going to print student grades. Now when I say average of student grades, then I have as my average is equal to that, and I can print my average. And of course we're going to use our beautiful F strings. So my average, and then I say average is this. I have an error here, and the reason why is that I have to put in S. So when I run it, you'll see I get the list here, and I get that average is of none. And the reason is because I did not return anything. If I return a 0, you'll see I get average of 0. But we don't want to have an average of 0 always, so we're going to calculate it. So how do we calculate an average? So how you calculate an average is that you take the sum of the elements and then you divide by the length of the elements. So I'm just trying to use every notion we've seen so far. So for loops, lists, and all this good stuff. So I can say for student grade in student grades. And then I can say, for example, sum is equal to 0, and I can say student sum is equal to student sum plus 1, but this is a bit lengthy, so I'm just going to use the shorthand, so plus equal 1. Also, I can now return student sum, but I have to divide by the length of the list. So over the length of students' grade. And by now you may be like, what the hell was he doing? You don't add 1, you're supposed to add the student grade. And of course I misled, so you have to add student grade. So let's verify. So I add everything and I take the sum, divide by the length of the student's grades. Alright. Let's see if it works. So an average of 67.6, and for me this looks perfectly reasonable. So let's say, for example, if I up this to 83, then it should be go higher. Yeah, and so as you can see, this does work. So this is very, very, very fun. Also, fun tip, I'm going to teach you how to write more concise functions, and this is by using functions that already exist. So I wanted to know how to calculate the sum of a list, but it turns out this already exists as a function. So I can just say return sum of students' grades over the length of students' grades. And if you run it, you'll see it gives exactly the same output, but you save much more lines. So I guess that's going to be it for functions. We've learned what are positional, keyword arguments. We've also learned what's the difference between an argument and a parameter. We've seen multiple examples of a function. And as a summary, I'm just going to say for functions, you put define, def, with the name of the function, parentheses, then the variables you're going to have as input separated by commas. At the end, you put a colon, you enter, indent, and then everything here, you can run code, and then when you want to give a result back to the one that invoked the function, you use the return keyword. And that's going to be it. Thanks for watching. If you like this content, like, subscribe, do all that good stuff. And in the next video, we're going to build a game. So guess the number using only everything we've learned so far. So stay tuned.